Let's take a couple minutes to review what we can do with synthetic division. So we're dividing these two polynomials. In order to be able to use synthetic division, you have to be dividing by something linear. So the polynomial we're dividing by, the x plus 4, has to be x to the first power. Remember, linear is x to the first. If it's not linear, we're going to have to use long division. Okay? So to set up synthetic division, you want to take what you're dividing by, which is called the divisor, and you want to take the 0 of it. So if I set x plus 4 equal to 0 and solved, I would get x equals -4. That's what's going to go in the box. Then we're going to take what we're dividing, which is called the dividend, and we're going to take the coefficients. And you want to make sure it's in degree order and that you're not skipping any degrees. If you're missing any degrees, you would need to fill in a 0. So we're going to take the coefficients of each term in degree order, and this one's not missing any degrees, so I don't need to fill in any zeros. Our first step is going to be to always bring down that first number. So we're going to bring down the 1, then we're going to take what's down here and multiply it by what's in the box. So 1 times -4 is -4, and then you're going to add these, and then you're always going to multiply what's down here with what's in the box. So that'll multiply to 20. These will add up to 0. 0 times anything is 0. 1 plus 0 is 1 times a -4. Add these, that's going to give us a -5, and then it'll multiply to 20 again, and then we end up with an 8. Okay, so what this last number is called, this is called our remainder. And the remainder tells us a couple things. Okay, first, it's going to tell us that x plus 4 is not a factor of this x to the 5th polynomial. And that is because our remainder doesn't equal 0. It also tells us that if I were to plug in -4 in for all these x's, I would end up with an 8. That's called synthetic substitution. So a lot of times synthetic substitution is much easier arithmetic than plugging in a -4 for all of these x's and evaluating it that way. So synthetic substitutions will typically keep the numbers a little bit smaller when you're trying to evaluate something. Okay? But what we're trying to do on this one is divide. So what our answer is going to be, these are our new coefficients. We started at x to the 5th and divided by x to the 1st. So synthetic division is always going to bring us down 1 degree. So this will be x to the 4th minus 5x cubed. I don't have any x squareds. Then plus 1x minus 5. And then how you write your remainder is plus 8 over what we divided by, our divisor, the x plus 4. This answer right here, this is what we call the quotient when we divide. And for your coefficients, you should always have enough coefficients to go 1 degree less all the way to the constant, and then 1 more for your remainder. Now, what we're going to do for the rest of these examples is look at a few more things you can do with synthetic division. So for this next example, okay, we're dividing two polynomials again, okay, and I know I can use synthetic division because what I'm dividing by is x to the 1st. Now, the difference between this one and that example we just went over is this one has a coefficient. So I know that if I do 9x cubed divided by 3x, that's going to give me 3x squared. Okay? But if you do synthetic division is not going to divide by 3 for you. So we have to do that first. So what I'm going to do is just take everything in this polynomial and divide it by 3. Okay? So what we're doing, I don't usually write this out, but for this example, I'm going to show y'all. So I usually will just divide everything by 3, but what we've done is we're GCFing out of 3 out of the numerator and the denominator, and not everything is going to be divisible by 3, but that's okay. We're going to get some fractions, but they're much easier to work with in synthetic division than they are in long division. Okay. So I GCF'd out the 3, so I'm able to cancel those out. So now these two polynomials are what I'm going to do my synthetic division with. Okay, so we're pretty much done with this one. Okay, this is what we're going to use for our division. So you're going to have a negative 2/3 in the box. That's the 0 of this. You're going to take your new coefficients that have been divided by 3. Okay, so if you skip the divide by 3 step for you, your answer is going to be 3 times what it should be. So anytime there's a coefficient on the x in the divisor, you need to divide everything by that coefficient. So then we'll bring down the 3, multiply it by the negative 2/3, add that, that's going to give us negative 4. When I multiply, I'm going to get 8/3. So 1/3 plus 8/3, that's 9/3, which is 3. Then I'm going to get a negative 2. Okay. So I'm going to go ahead and write this with a common denominator, so negative 6/3, and that'll make my remainder negative 4/3. So these are going to be my new coefficients. This is going to be the remainder. So I started at x cubed, so I'll be at 3x squared minus 4x plus 3. Now the remainder, you always put it over what you divided by, which is this reduced one. Okay, we're not going back to the one with the coefficient. Okay, what we did synthetic division with were these two polynomials after we have divided by 3. Now for your remainder, you can't have fractions and fractions, so you're just going to multiply by that common denominator, and that'll give us plus a negative 4, or just minus 4, and then distribute that 3 back in, and that'll be 3x plus 2. And this right here is your answer. Now another thing you can use synthetic division for is to help you factor. Okay, so we want to completely factor this polynomial given the factor 5x minus 2. Okay, so we know that since it's a factor, that means our remainder should equal 0. If we do synthetic division and our remainder isn't 0, we've done something wrong. Okay, I'm able to do synthetic division because this is an x to the first. So what we're going to do synthetic division with is 2/5. You just set that equal to 0, add the 2, divide by 5. Okay. But since what I'm dividing by has a coefficient, we have to take all of these and divide them by 5 before we do the coefficient. I'm not going to worry about dividing this one by 5 because I know that I'm not going to have a remainder, so I'm not going to have to write it over x minus 2/5. So I'm going to put 2/5 here in the box. My new coefficients are going to be 1, negative 12/5, 4/5, 40 divided by 5 is 8, negative 96/5, and then 32 over 5. So we're going to bring down the 1, and I know we have a lot of fractions, but they're all going to work out pretty easy. 2/5 times 1 is 2/5. This will give us negative 10/5, which is negative 2. Then when I multiply, that's going to give me negative 4/5, so that'll zero out. And then that's going to give me 8. This is going to give me 16/5 when I multiply the 8 by the 2/5. This is going to add up to negative 80 over 5, which is going to give me negative 16. And then when I multiply that with the 2/5, that's going to give me negative 32/5, which gives us a remainder of 0, which is what we wanted. Okay, so now to completely factor, okay, this is going to be the polynomial we're left with after we divided by this. So we first need to be sure to include 5x minus 2 as one of our factors. Then this is what we're left with. So that's going to be x to the 4th minus 2x cubed, no x squared, 8x minus 16, and this time there's no remainder. Okay. So what I need to do is continue to factor what's left. So I'm going to factor this by grouping since there's 4 terms. So here I can take out an x cubed. I'm left with an x minus 2. Here I can take out an 8. I don't need that parenthesis I just drew. And I'm left with an x minus 2. So what this 4-term polynomial will factor into is x minus 2, and x cubed plus 8. Okay. This is a sum of cubes, so I can continue to factor that. So remember, you cube root it. Okay, then you square that, change this sign, multiply these together, and then square the 2. Okay, and then I'm going to bring down my 5x minus 2. So this is the completely factored form of this polynomial. If I were to refoil all of this out, I would go back to this 5x to the 5th polynomial. Okay. So now something we can do that's similar to this is use synthetic division to find all of the zeros. Okay. So this time they gave us 2 zeros, so we're going to do synthetic division twice. Okay. So I'm doing synthetic division with a 1/2. So this means, remember this 1/2, this came from a 2x minus 1. Okay. So what I'm going to do first is divide everything by 2. Okay, so if your coefficient, or sorry, if your 0 is a fraction, you want to divide by the denominator. So that's going to be 2, 2, negative 25 over 2, negative 1/2, and 3. Now, when you're finding the zeros, if you forget to divide by 2, your answer is going to end up reducing down. So when you're finding the zeros, if you forget, it's going to work out to give you the same answer. If you're finding the factors and you forget, it's going to give you an answer that's a multiple of what you should have gotten. So I'm going to bring the 2 down, multiply that. That'll give me negative 3/2, positive 3/2. That'll add up to negative 22 over 2, so negative 11. Then I'm going to get negative 11 over 2, so negative 12 over 2. And then I'm going to get negative 3, which is going to give me a remainder of 0, which is what I wanted because they told me it was a 0. Okay, so then I'm done with that remainder. I'm going to take the second one and do synthetic division one more time. And you don't need to use the remainder. Once you get a 0, you don't use the remainder again. This is going to be our last term. So that'll be negative 6, negative 3, this will be 9, negative 2, positive 6, again to give us a remainder of 0. So then I can take this polynomial, 2x squared minus 3x minus 2. Okay, we're looking for the 0, so we're going to set it equal to 0, and we're going to factor it to solve. And so what multiplies to 2 is just 1 and 2. So the 2 is going to have to go over here since I can't put common factors together because there's no common factors here. And then that's going to give me negative 4x plus 1. That'll add up to that negative 3. So I'm going to get my last 2 zeros to be negative 1/2 from this one. Subtract 1, divide by 2. Add 2 over here. So that's 2 zeros, but I need 4 because this is an x to the 4th polynomial. So I have to be sure to include these. So I'm going to have negative 1/2, 2, positive 1/2, and negative 3. And that will be all 4 zeros.